Guys, today we're going to do some right triangle trig. You're more familiar with this as SOHCAHTOA. We're going to find angle measures and lengths of sides of a triangle that are missing. Remember to show your work so that you can get credit. By that I mean you need to show me where you've set up the equation in order to solve. And you'll see in just a second. Recall sine of an angle equals the opposite leg over the hypotenuse. That's how we get SO, opposite over hypotenuse. Cosine of an angle equals the adjacent leg over the hypotenuse. That's how we get CA. And tangent equals the opposite leg over the adjacent leg. Remember, these are equations. The angle measure always comes after the word sine or cosine or tangent, and we're going to plug in the values. So let's check out number 1. Solve each triangle. Notice that in this particular triangle, we are given two sides, and let's say we want to find angle A first. So we would say, what have we been given? We've been given the opposite side, and we've been given 12, which is the hypotenuse. So we've been given the opposite leg and the hypotenuse. That spells O. That's the O and the H. So we're going to use sine of angle A equals the opposite leg over the hypotenuse. This is what I mean by showing me the equation that you used to set it up. Anytime you're trying to find the angle, you will use inverse sine. So in your calculator, it's the inverse key. So you'll have inverse sine, you'll type in 10/12, hit enter, and your calculator will give you the angle measure. We're going to round to the tenths. And I came out with 56.4 degrees. Make sure your calculator is in degree mode. Okay, all right, when we solve the triangle, that means find all of the missing sides and angles. So if angle A is 56.4, then we can find angle B. To find angle B, we're going to take 180 minus the 90-degree angle minus 56.4, and I came out with 33.6 degrees. In this triangle, since we were given two sides, we can find the missing side, AC, by simply using the Pythagorean theorem. So this is a good review for that as well. So we have AC squared plus 10 squared equals, the hypotenuse is always your C, so 12 squared. I finished that off. AC squared plus 100 equals 144. AC squared equals 44. Take the square root, and AC equals 6.6. And that is called solving the triangle. We found the two missing angles and the one missing side. All right, let's check out number 2. In number 2, angle A is given, so we could easily find angle B. Angle B is 180 minus 90 minus 64. And we find angle B is equal to 26 degrees. Now we need to find side BC and side AB, those two sides. All right, notice that in relation to the angle that's been given, in relation to the 64-degree angle, 7 is the adjacent leg. BC is the opposite leg, and AB is the hypotenuse. So I like to identify the sides. Let's say we want to find BC first. Let's find side BC. So that is the opposite leg, and we're given the adjacent leg, so that would be tangent. So we're going to say the tangent of the 64-degree angle is equal to the opposite leg, which is BC, over the adjacent leg, which is 7. We'll multiply both sides by 7 to find BC. So 7 times the tangent of 64, and we want to make sure we're in degree mode. And I came up with the length of BC as 14.4. Now let's find AB, which is the hypotenuse. I would not use 14.4 just in case I missed it. I would stick with the 7 to find the hypotenuse. I'm going to use the adjacent leg and the hypotenuse. That would be cosine. So I'm going to say the cosine of the 64-degree angle is equal to the adjacent leg, which is 7, over the hypotenuse, which is segment AB. I'll solve this. To find AB, you are going to end up dividing 7 divided by cosine 64, and it equals 16. And there you have it. Y'all have a great day, and there's a worksheet for you. Make sure your calculator's in degree mode.